Well, I spent the last 20 years working for a company called Worldcast Systems, which wasn't even called Worldcast Systems when I joined them back in 2005. They were known as Automat-Aztec at the time. French company based in Bordeaux. They became known in the US for their FMB80 RDS encoder and the early Golden Eagle FM monitors, frequency agile FM broadcast monitors. When I joined the company, we were just introducing the Golden Eagle HD, which was the first on the market effective monitor for AM, FM, IBOC hybrid broadcasts, analog and the IBOC digital broadcasts. We followed that up with a product called the Relio, which was basically built to order for Clear Channel Communications here in the U.S., but then also proved popular with EMF and a couple of other the big broadcasters as a facility control device. Um, and that's where I got involved in using SNMP because we made the decision early on to integrate SNMP into the software of this broadcast facility control device, and it opened up a new window for a lot of our customers. So I spent, like I say, close to 20 years with the company. Managed the office in Miami for a number of years. So I was responsible for sales and support for all of the Americas, Canada, the U.S., and Latin America as well. Um, did a couple of projects that I can recall in Canada, but that was many, many years ago. And so a couple of years back, the company let me move from Miami, which I didn't care for Miami. I was down there for a long time, but I grew up in the countryside of Ohio, and Miami was too flat, too hot, too crowded. Everybody just seemed angry all the time. It was not a happy place for me. So I was happy to move back to Ohio a couple of years ago, and then the company and I parted ways at the end of June of this year. So I am currently working as an independent contractor. My business is TP Techno Limited. So I'm doing independent broadcast and IT consulting and helping out on some projects here and there where I can find the opportunities. So, I guess we'll just move on. Like I say, we got involved in SNMP. Our software guys decided to integrate this protocol into our facility control software, and it's all about doing more with less. So that's the kind of the common theme in broadcast engineering worldwide is there's more stuff that broadcast engineers need to be responsible for. We've got streaming, we've got podcasts, we've got websites, we've got, even the radio guys are having to put TV cameras on now and do live streams of the morning shows and all this kind of stuff. But we're given fewer resources typically to do that with, fewer personnel, smaller budgets. So we have to find ways to do more with less. And SNMP also leads you to another term that I like to use when talking about broadcast engineering, and that is omniscience. The broadcast engineer should at least maintain the aura of omniscience at all times. People should have the impression from you that you always know what's going on everywhere with every part of the plant. So it's having complete or unlimited knowledge, awareness, or understanding, perceiving all things. Um, SNMP can help you become that sort of mythical omniscient engineer. Or if you want to look at it another way, the more you know, the better decisions you can make. So SNMP is at its heart, it's another way to connect to a piece of equipment or many pieces of equipment and monitor and control it. So we've had lots of different ways to connect between our facility control unit and the stuff we're controlling, traditional hardwired I/O, what I call pinball logic, relays, contact closures, analog voltages, that kind of stuff. A lot of equipment came with serial interfaces, so it had proprietary protocols or use simple text and response, kind of a terminal type protocol over an RS-232 link. So now we've got those connections and controls can happen now over a network connection. And of course, you're all familiar with the built-in web user interfaces in a lot of different pieces of equipment. SNMP is sort of a level below that. It doesn't require a website. It happens kind of in the background, and doesn't interfere with any other stuff that might be going on over the network. So we've had for a long time, we've had ways to connect from, over the network to the facility control unit, but now we can use those network connections now between the control unit and the controlled devices in the field. So, used to be we could connect to the control unit. Now we can connect to controlled equipment also using TCP/IP network type connections. So several different ways you can use that kind of a network connection. You can ping a piece of equipment and get a response back. It says, yes, here I am, I'm online. You can monitor that over time. And if the ping is not returned, if it's not answered in a certain number of cycles or a certain amount of time, you can use that to trigger an alarm. That will send a text message or an email or light up something in the control room, let you know that something is amiss. You can also get data. You can do a get command and say what's your forward power, what's your temperature, what's your voltage, what's going on, and get the data back, and that can then be graphed or displayed with indicators and stuff on the control software. Set thresholds, monitor that, and trigger alarms as well. You can also control things with what's called a set command. So you can, using these SNMP commands over the network, you can actually turn things on and off, change settings or parameters, and whatever it is that you need to do. So the first question a lot of people ask when we start talking about SNMP is, well, what's it good for? What can you do with it? So I used as a real world example Josh Haddon, who's a good customer of ours, a chief engineer for iHeartMedia in New York City. Um, I first put this presentation together probably more than 10 years ago, and I sent it to him for his approval. He says, wow, he said, that's a really old picture of me. He says, I look like I'm 12 years old in that picture. I said, Josh, you are 12 years old, but notwithstanding, I said, all right, well, send me a current picture of you at work, you doing your job, Josh. So he sent me that. And I said, okay, well, uh, whatever form Josh takes, he's got a lot on his plate. So he is responsible for a lot at the Clear Channel facilities, iHeart facilities in New York City. Of course, he's got his two big transmitter sites, Empire State Building and 4 Times Square. He's got his studios. He's responsible for all the communications and IT. They work under him. It's not a separate department for them. Of course, all the master control facilities, generators. He's responsible for the building security, for access to their studios. He's, of course, responsible for the HVAC. They've got a complete backup facility across the river in New Jersey. So it's a lot going on for Josh. So anything he can do to kind of lessen his workload, because they're cutting his budgets and staff as well. So formerly, before he got involved with the SNMP and the reliable remote control stations, this is what he had to do with the old Burke controls to change a transmitter site. So he would have to call the transmitter at Times Square, make sure that the coax switch is set, and ensure to turn it on, take a set of readings, and then he would call the Empire transmitter and turn off the transmitter auto switch, turn off the AV, and so it's a lot of button pushing, a lot of time, and that's just for one of the 4 stations they had at those facilities. So that was a lot of work just to change operations from one site to another for one station. With the SNMP and the Relios, now he's got control units both at Empire and 4 Times Square, and they're constantly talking to each other. They're sending data and sharing information, status stuff back and forth. So now all he needs to do to change transmitter sites is connect to any of the control units. He's got one at his studios as well. He can connect to any one of the control units. He flips a little safety switch to enable the transmitter control, and then just select which stations to switch. And so the software and the SNMP communications then do all of this for him. So they verify the coax, they verify all the readings, they mask the alarms, they shut things off, they confirm the new ones on, verify the PPM codes are present. All that's done through SNMP. So that makes Josh happy because he has more time to eat his hamburger. Part of the scripting that they did, this is at a time when Doug Irwin was working with Josh in New York City. Doug has since been moved out and is now the chief engineer for the Los Angeles market for iHeart. So they constructed what they called a doomsday link. So they wanted to monitor the transmitters at Empire State Building. That was their primary site. And if any of those stations were knocked off the air for whatever reason, they wanted the site to, double check, confirm that the Empire building, the transmitter there was off, and automatically turn the 4 times square transmitter on to continue broadcasting that particular station signal. So that doomsday script, that subroutine, was in the software for many years until it finally paid off on a Friday afternoon. There's the message from Doug. He said he got an email and a phone call from one of the Relios, the facility control units. The Z100 transmitter at Empire State Building had some water leaked into it from the ceiling above, knocked it off the air. The auto switch script did its thing, flipped the operations over, turned Z100 on over at 4 times square. And the payoff line is no one aside from engineering even knew what had happened, because they're not monitoring off the air anymore with HD. So it's like nobody had a live feed. Nobody knew the station had even gone off the air. Even engineering didn't know about it until it was already fixed. And that's, to me, that's kind of like one of the primary goals of any engineering effort or any equipment manufacturer. It's like the self-healing problem. It's like, fix it, get us on the air, then tell me what happened. I don't want to have to go rushing down to the site and flipping switches and transferring this, that, and everything. Get it fixed, let me know what happened so we can keep it from happening again. So one of the things that they built into their views here. This is again for Z100. We're looking at the Empire State Building transmitter site, so you can see all the typical things. There's your on-off controls for the transmitter, your transmitter B, your antenna control switch. You can see the forward power, any alarms. But there in the bottom of the screen is another tiny little set of controls. That's the set of readings and controls for the Z100 transmitter at 4 times square. Now he's looking at the unit at Empire, but from that same unit in that same interface, he could go in and click the buttons and turn the transmitter on at 4 times square without having to connect to a different device. So that's, again, one of the things that you can do with SNMP. One of the other things, kind of a simpler, the iHeart was our launch customer for the Relio with this SNMP capability. So a lot of the early examples are from iHeart stations. And one of the things they loved was, like Brett Gilbert in Tulsa, he had a lot of different transmitter sites. I think he had 4 stations, but he had 5 different sites between main and backup sites scattered around the city of Tulsa. So he was able, for the first time ever, to build a single page monitoring for all of his transmitters. So on one page, from looking at one of his Relios, he could see the readings and access controls or whatever he wanted to do on any of his 5 transmitter sites in one window. So that was a big early adopter. Steve Frick out in San Diego, again, it was the first time he was able to put his power readings and everything, indications for all of his transmitter sites, all of his stations on one page, and see that status at a glance. So that was an early popular thing. So WLS, they of course were part of ABC Disney, and they had decided to cost cut, surprise, surprise, and farm out their program switching to a company called Encompass in Atlanta, Georgia. It's still one of the most impressive facilities of any kind I've ever seen. Enormous satellite switching. They handle the program switching for dozens of cable channels, local TV channels, networks, all that kind of stuff. It's room after room of, well, I'll show you a couple of pictures, but anyway, they wanted to be able to monitor at their 8 transmitter sites. So this is ABC coming to us, and just for the 8 sites where ABC actually owned the stations. So it's the O&O markets: New York, Los Angeles, Chicago, Philadelphia, Houston, Dallas, Fresno, and I think Charlotte. I think there were a couple of those smaller markets that were, you wouldn't think of as being the ones that ABC would own. But anyway, they wanted to be able to monitor and control all of their transmitters at the O&O stations from Encompass Digital Media in Atlanta. So we came in to do it. The rules with it, they so we set up an SNMP project at SNMP at WLS first, and they liked it so much because they were able to monitor so much more detail about their transmitters and stuff. So then ABC asked us to do the 8 O&O stations. So we had a very short time frame. The system could not interfere with any existing remote controls that the stations had hooked up. They just wanted basic readings and be able on, off, raise and lower power. 8 markets covering 11 sites, 19 transmitters totally, and give all of that information and control to the central access point there in Atlanta. And another aside, um, of the 8 O&O markets, they all had existing remote control systems installed except one. New York City did not have a remote control system. They had live engineers 24/7 up until we put this system in whatever it was, 2015. So it was fairly simple. All of the transmitters were Harris, or almost all the same model. We had a couple of Diamond and Maxiba, one Power CV, but most of them were Harris Platinums. So the MIB structures, we'll tell you what a MIB is here in a bit if you don't know. The commands were all very similar. And here's an OID, which is an object identifier. And again, we'll describe that here in a bit. So that's an OID for one of the data points in one of their transmitters. So that would give you a forward power in percent from a Harris Platinum station. So with that information, I spent about a week working at the top of the Willis Tower in Chicago. We were able to connect all the transmitters across the country, get all the controls verified, switching from transmitter A and B, transfer switches, power readings, emergency status indications, everything that they wanted, and build a very kind of unified so that all of the screens in Atlanta would have a similar look to this one. So we were able to customize a little bit. We were able to add contact information for the different markets. So if there was a problem, the people in Atlanta would have the phone numbers right there. We're also able to customize the names of the transmitters. Houston decided to call theirs Mickey, Minnie, and Goofy. So, keeping with the Disney theme, but, that was easy to change those labels so that, again, the people in Atlanta and the people in Houston could be talking the same language when they were communicating about some sort of issue. And so that was the system that we put in. So that's the ABC monitoring room at Encompass. Now, ABC has since ended their agreement with Encompass, and they're now doing this with their own facility and their own people in Houston. Same kind of look though. You've got the different stations for each of the markets. There's Fresno, by the way, so you can see the program flow, the quality of the picture at each different stage. You can see, various bits of information about the program flow and what's doing what. Down in the lower right, you can see this kind of red and green bar. This monitor here down in the lower right with the green squares on it, that's our broadcast monitor software. It was called World Broadcast Manager, I think, when we first put it in, but that was monitoring the devices at each of the 8 markets around the country, and just basically giving a red or a green if everything was good or not, and then they could dive in and get more detail if they wanted to. Another project that we did with SNMP that I was quite proud of was for the NBA. They refreshed their codecs. So from all of their contributing markets, they each have their own codec. Some markets have one flagship station, some have 2 flagship stations for markets that have English and Spanish broadcasts. So all of the audio from all of those codecs from all over the country comes into their facility in New Jersey, Secaucus. And there it's decoded. So we got it was 42 streams at the time. So you got your 42 program streams coming in from all the different markets, hits the decoders in Secaucus. The audio is decoded and distributed on their regular satellite networks for all the affiliate stations. We're also able to decode and send a stream or forward a stream transcoded for Akamai, which is their streaming service, their web service. So on the NBA apps and all that kind of stuff, they would get that audio as well. What they wanted to be able to do was to hear the audio coming in from any one of those 42 markets in the NOC, in the Network Control Center in Secaucus. And so rather than do a patch panel with all the, or some kind of switching device or this, that, or the other thing, we could simply use SNMP and software that we call ScriptEasy. That's our facility control software. So in this monitor decoder down there in the lower left, that's the NOC in Secaucus. So that decoder there could actually request a copy, an additional copy of any one of the 42 streams. So you would hit a button and this would send an SNMP command to the codec saying, send me an additional copy of the stream from San Antonio, English stream from San Antonio. So that would get another copy sent there, and that would be played out on the speakers in Secaucus in the NOC. So again, they could select any one of the 42 streams, just like an audio switcher, except it doesn't physically exist. So that's the interface that we built for them, so they could click any one of the markets and hear the audio from that market, and then confirm that the audio was of sufficient quality for broadcast. Any questions as before we get kind of down into the details and the dirt? That was just kind of on the applications, the benefits. You can save time. You can monitor and control things that you couldn't monitor and control before. Like servers and switches and all that IT infrastructure, all that stuff speaks SNMP. There's a lot of broadcast equipment now that is more and more supporting the SNMP transmitters, RF switches, monitors of all kinds of devices, your IT stuff, your HVAC stuff, almost anything with a network port speaks SNMP. So you've got a wealth of information, often too much information. So a lot of it, the application is to identify not only the data points that you can get, but the ones that are useful to you and that you want to get and monitor. And of course, any of this can happen anywhere on the network, anywhere around the world. All right, so SNMP, Simple Network Management Protocol. You'll notice simple is in quotation marks because until you kind of get your head wrapped around it a little bit, it can be a little, and like anything computery, it's very finicky about the syntax. So, one little dot or a colon or a semicolon in the wrong place, you've got to be able to sort of think like a computer and get it done the way they want. It's UDP based, very light protocol. The framework was defined way back in the 80s when they were first putting together the what we now call the internet, and they needed to be able to reach out and get data and control various switches and stuff like that on various ends of the network connections around the country. Basically, SNMP is a communication between a manager, what's called an SNMP manager. That's the one that's asking the questions or sending the commands. The controlled equipment has a piece of software in it that's called the SNMP agent that receives those queries and commands from the manager and responds to them. So each data point in a piece of equipment is assigned a number called the object identifier or OID. So again, that's a typical OID right there. And it's again, once you kind of know what those numbers mean, you know what are the important ones. Um, Once you identify the object, the data point that you want, you can do a couple of different things with it. Basically, get and set. So you can get a piece of data. So the manager reaches out to the agent, retrieves that piece of data, or you can set. The manager sends a command, says change the value of this data point to, and then the response comes back from the agent after that's done. There is a third type of SNMP message called the trap, which has a subform called the inform V2C. Those are the only ones that are actually generated by the agent. Everything else is done as a response to something coming from the manager, but the traps and the informs, those are something that the agent does on its own based on some sort of a anomalous reading or condition in the target equipment. So if something goes wrong, the trap can be sent. The manager can get the trap and go, "What's up?" Well, this agent says something's wrong with this piece of equipment, and then you can get more detail and stuff like that. But that's kind of like the emergency flag that you can send to let people know that something is not great. So there's the OID. It's written in abstract syntax notation one, and they are all collected. All of the OIDs when a piece of equipment is released, the manufacturer typically will publish all of the OIDs in what's called a management information base or MIB file. So having the MIB file for a particular piece of equipment is really key to be able to unlock the potential of what's in there. It's not absolutely necessary, but it sure as heck is helpful to have the MIB file. Um, so those are the commands. So here's what the MIB file looks like in a MIB browser. We'll tell you about a good MIB browser you can get if you don't have one already. So it's a menu basically of all the data points in a particular device. In the MIB browser, the iReasoning MIB browser appears like this directory tree type structure. So some of the numbers in that OID, that long string of numbers, represent different branches of this MIB file, different branches of this directory tree. It is worth noting that the numbers don't necessarily all have to be consecutive, right? You might be going down a MIB tree and you might see 1, 2, and then 5. And they just leave out 3 and 4 because they don't need them. You might see 1, 2, 6, and then 5 because they don't necessarily have to be in numerical order either. So it's um, so that's kind of how the structure works. And the OIDs are typically truncated when you see them in the MIB file. So they will use uh, there's a punctuation indication that says from the previous branch. So in other words, for the NEC TV transmitter branch of the MIB file would say from the NEC product depend branch. This is sub tree or sub branch 1 or sub branch 4, whatever it is. And then this one would be from the NEC TV transmitter branch. This would be sub branch 1 or 2 or whatever it is, however they want to number it. So important to have a MIB browser to integrate the standard MIB files. There are standard MIB files, RFCs typically, that have been published over the years. They do basic things like define what is an integer or what is a floating point number, that sort of thing. So a lot of the MIB files that the manufacturers publish will call or integrate, import those standard files so they can import those definitions without having to rewrite them and reinvent the wheel every time they do a MIB file, create a MIB file. So you get a MIB browser, you can view the structure of the MIB tree, you can see the OIDs, and you can actually test the functions. You could do get and set commands from the MIB browser and see what kind of data comes back. So the MIB browser I use, a lot of people use this one, very popular one. It's not the only one. They do have a free version from iReasoning Network, so you can go onto their website, iReasoning.com, and find their MIB browser there. If you already have a MIB browser that you're familiar with and you like, that's fine. This one has proven to be pretty simple and useful for people who are sort of new to the whole concept of SNMP. So in the MIB file, here we are looking at this is from a NEC transmitter. So it's a NEC transmitter MIB. And we can see this on-off control that we've selected in the MIB browser. It's got a little icon of a pen nib, and that means that is a read-write icon. That's a read-write value. That's something that we can change with a set command. So we can read it with a get command. We can change it with a set command. And here it gives you the syntax. It's an integer. So if you want to turn the transmitter off, you would set that OID for a value of 1. If you want to turn the transmitter on, you would set that OID for a value of 2. And here you can see the OID up here in the top of the MIB browser, and there's the operations over there to the right. So that's where you select whether you want to do a get or a set. There's also a couple of other commands that are called walk, which can help you if you don't have a MIB file. You can literally walk and query every data point that can be found in a particular piece of equipment, and then go through and sort through them and hopefully find the ones that you want. Um, it's important to note that the first 6 numbers of the OID are going to be identical in almost every instance, 136141. It's just kind of the way the OIDs are written. They're written from a very broad context. So the 136141, it's like you're defining your street address with starting with the known universe, and then the Milky Way galaxy, and then the particular arm of the galaxy, and here's a solar system. It's like then you get to Earth, then you get to the continent, then you get to, so it's all derivative. So the whole OID works off what came before. So the first six numbers, one just recognizes that this is an OID that is recognized by the ISO, specified ISO recognized organization. The six is a salute to the Department of Defense for their part in creating the internet. The following one means it's an internet OID, belongs to a private organization that's a business enterprise. So after that first six numbers, the next one, the 5299 in this case, that's an important one because that tells you who the manufacturer is. Those are all registered. So if you see an OID come back from a piece of equipment, which we did, as a matter of fact, in the Chicago install, when we were doing the ABC work, we were quizzing a transmitter in one of the markets, and it was giving us just incomprehensible. Would say, tell us the value of this, and it would come back with something that just made no sense at all. And so we were trying to figure it out until we just scanned the OIDs and saw that the number that followed the 136141 was not the number for Harris, for Gates Air. It was for some lab at the University of Southern California. And so, well, that's kind of weird. So we rebooted the controller in that transmitter, and things settled down. So it had gotten confused and gotten some bits mangled somewhere in there where it was returning the wrong OIDs for the queries that we were sending. Um, so the manufacturer number, you can again look that up. You can go backwards, and then everything after that manufacturer number, that's going to be in the MIB file. So that's stuff that is defined by the manufacturer when they make the OID in the MIB file. So in this case, the 15 means it's a remote control system. The 42 means it's the Relio. It's a system OID, belongs to the app, to the script easy. It's part of the actions table. It's an actions entry, action state. So that basically this is a action button, control button in the software, and you can define in the MIB file before the unit is marketed and before the MIB file is published. You could define all the way up to, yes, this is an action button in the script easy software, but the user has the ability to create more of those buttons. So they're all user created. And so we can define a button, but for a specific button, you need what's called the index value. That's something the software generates every time a new button is created. It adds the index value at the end. And so that takes it from being a button in ScriptEasy to being this specific button in ScriptEasy that you're triggering or reading with your OID. And so that an OID, an object, can have multiple index values. So you could think about it as like a table form. Say a network switch with 64 ports. Each port has 6 different parameters that you want to measure. So instead of manually plotting out a specific OID for each one of these 64 ports, you can use index values, one for the port number, one for the value that you're trying to get. And that way you don't have to handwrite and likely make a bunch of mistakes by trying to define specific OIDs for each one of those data points. You can do it as in kind of a tabular structure. So there's a little bit more talking about the index value. So this is talking about the, some of the values, some of the OIDs can't be completely defined in the MIB file because they didn't exist when the MIB file was published. So again, that's a generic button OID as opposed to a specific value. So looking again at the MIB browser, you've got the agent IP address. So the IP address in the upper left, that's the piece of equipment that you're trying to talk to. You've got your MIB tree here with the green leaf icons for read-only, the pen nib icons for read-write. We're looking at a Nautel NV transmitter here. When you select an OID in that table, you get the description of it down there, what syntax to use, because an OID can return almost any kind of data. It can return an integer, it can return a floating point number, it can return an IP address, it can return another OID. It can return a text value. So there's lots of different data types that can come back from the OID, and that's where you find the description of what data type you can expect. Also important if you're going to get into SNMP to have Notepad++ or some kind of an advanced notepad, because the MIB files sometimes are not formatted for the basic text editor. So if we look at, there was a Toshiba UPS that I worked on. It was part of Josh's facility in New York City, and he was kind enough to let me get in, play around, and try some different things. So it's a Toshiba UPS. So if you look at that MIB file in a regular text editor, it looks fantastic. So all organized. You can see here the imports that they're bringing in from the RFCs, right? Those standard MIB files defining the different object types and things like that. So they don't have to redefine them in this MIB file. Here's a Europa Divicom Europa transcoder. It's a video transcoder. If we look at that MIB file in a standard text editor, it looks like that. So that's not, not so easy to read. You can see, well, there's the imports. So that's, that is a MIB file, but it would be hard to read otherwise. So if you put that same MIB file into the Notepad++, then it's easy to see the import. So there's that punctuation on it, the double colon equals sign. That means it's defined from the previous branch of the tree. So if we look at, well, here's a 5-air microwave IP link. This is another one of Josh's toys from New York City. Uh, Pretty simple device, right? Has two transmitter slots, two receiver slots, sends data across a microwave link. And you think, yeah, it's a pretty simple device. Should have a fairly simple MIB file. No, that MIB file is 288 pages in Notepad. So huge advantage to having the MIB browser there because you can see the trees, the different branches. And so it's a lot easier to wade through all of that information and find the stuff that you actually want. So you can walk the MIB, but if you tried to walk the MIB on that 5-air microwave IP link, you would have to come back next Tuesday. So lots of tables in that MIB files, and when you're doing a walk operation, it's going to query every possible iteration of every value on that table. So again, much better to see the directory tree structure in the MIB browser and pick and choose the OIDs that you want to test and and integrate into your system. So here we are back on that microwave IP link, and I want to get the status. So I'm trying to get the read-only XID receive level of the signal. So you look in the definition in the lower left. So it's the receive level of the signal transmitted by the device. Displayed in dBm. Yeah, that's a useful value. We probably want to measure that, see if we got pigeons standing in front of the microwave or something like that. So pick it. There's the OID. I do a get operation, and let's see, OID. I'm going to hit get and get back. No such name. Well, what? What do we miss? Well, look at the top of that column there in the MIB browser. You see a little key icon. That's an index value. And so that OID that I clicked on needs an index value to tell it which specific piece of data you want to get. Now, in this case, the index value, when I look at it, is going to be let's see. Okay, so yeah, status ID. If we look at that OID, it says it's in drawer 1 or drawer 2. So those are the two slots in that 5-air microwave link. So we want to know which receiver we're going to query to get to this particular receive level that we want to get. In their wisdom, they decided to indicate drawer 1 with the number 3 and drawer 2 with the number 4. So why those are the index values for drawer 1 and 2, I don't know. So I could find that again by doing a little walk operation. Then I could see here's the temp, here's the Fahrenheit temp. So then if I do the receive level, and I've got that in the receive level, and then I add the .4 at the end for drawer number 2, then I got my minus 44 dB strength when I did the get command. So again, you got to kind of know your way around, read the icons in the MIB browser, and find out what you're doing. So here's that Toshiba, the UPS system we're playing around with. It's a Toshiba G8000 series, and I could tell because I asked the unit. Right there. It says UPS ident model. So I do a get command on that, and it comes back and says, oh, it's a G8000 mm series with this voltaging. You could query the status, you could query the serial number, you could, you know, it's all there. The Toshiba MIB is very well arranged. It's only 42 pages, has good logical categories. Some MIB files are easier than others or more organized than others. Some just put all the OIDs in one big file. They don't, separate them or categorize them in any way, and that's kind of a pain in the butt, but it is what it is. But this one's pretty easy to go through and find out, like, say, how many minutes remaining. So we could go through and say the estimated battery minutes remaining, estimated time to the battery charge depletion under present load conditions. So that sounds like a useful thing to retrieve. So we'll do a get command on that and fit that into it. So once you have all this information, and again, there's hundreds or thousands of data points in each piece of equipment. So a lot of the grunt work, a lot of the work in getting SNMP up and established is drinking from this fire hose and finding the one or two little droplets that you really want to keep an eye on. And so you find those, and then you need to integrate them in some sort of monitoring software, right? Something that can query and quiz automatically, repeatedly, and monitor things, let you know if a status changes or something goes beyond a certain threshold. Typical NMS systems, network management systems, don't have that kind of automatic monitoring. They're designed for people to click on and say, give me this or give me that. They also don't, some of them don't have alerting capability. So if you're going with an NMS system, you need to make sure that it's going to respond or going to do the things that you need to do in terms of keeping an eye on everything 24/7 and either initiating automatic actions like we did with the ABC or the Doomsday Switch in New York City, or alert somebody when something goes out of tolerance. I mentioned that there are a lot of different things that speak SNMP. Here's some of the more broadcast oriented ones. There's a vast universe called SCADA, which is systems control and data acquisition. And there's a lot of equipment out there that speaks SNMP and you can find almost any iteration you want. So instead of having a control unit with everything physically connected to that control unit, one of the things Doug Irwin did, he had an old BE transmitter that didn't have any kind of a network connection at all. So he put a small remote control, installed a small remote control unit, a little bit like that Denkovi over on the right side there. This one installed one of those inside the transmitter. And he made all his connections for his controls and his reads and everything there, and then ported that network out, and that speaks SNMP. So now his old BE transmitter speaks SNMP. So BDI makes some really nice stuff. There's all sorts of data probes you can buy, different devices that have exactly the combination of relay closures, status indications, analog inputs that you want for particular sites. So you can have this kind of central software working on the network and then just put a little bit of physical I/O specifically in the places where you need it. So your cable runs stay short and everything works out very nicely. That's another new wrinkle, the DNF controls. That's just simple button panels, indicator and button panels that speak SNMP. So you can use those in all different kinds of facilities. Um, and it's important to remember that, borrowing from the Hitchhiker's Guide to the Galaxy, don't panic. When I was doing, like, in the first year or so, I was talking about SNMP. My boss was in Miami, and I was giving a presentation to the local SBE chapter, and he happened to be sitting next to the director of engineering for one of the major broadcast groups there. And as I was wrapping up the presentation, he leaned over and says, "So, what do you think?" And the guy was saying, I don't have time to learn this. I don't. It's like, it's one more thing. It's like, no, no, don't panic. You don't have to. It's just one more way to connect with and control equipment. It's a way to get more data that you can use to make informed decisions. It's a way to monitor different pieces of different types of equipment that you weren't able to monitor before. Just play around with it. Get the MIB browser, get some MIB files for your equipment. You can contact the manufacturers typically to get those. Start poking around and see what you can find and what might be useful to you in the long term. That's SNMP at its best. So that's what I got. We got a few minutes for questions. Happy to talk about any subject, whether it's SNMP or legacy automat gear. I do have a bit of experience with that. Um, I appreciate you having me over and sharing your time with me.
Thank you, Tony. This has been very informative and very specific to what we do because there's a lot of rabbit holes you can go down with SNMP. I have one question in your experience, uh, on these projects building, monitoring, access and control systems for various clients. Have you come across any modern day equipment that is stubbornly non-compliant or has MIB files that have fewer OIDs than you would like? Is that something you've encountered with equipment or any particular manufacturer in this modern day and age?
Yeah, it's funny. I haven't seen kind of the underpopulated MIB files. Typically, if a manufacturer is going to put a MIB file together, they're gonna do pretty well. I have encountered a manufacturer or two that will refuse to share their MIB files, which kind of struck some concern in some of our customers because they're like, "Hey, we'd like to connect this piece of equipment. Can we get the MIB file?" The manufacturer says, "Well, no, but we'll give you a specific OID if you ask for, a specific data point. We can give you the OID for that specific data point." So, I don't know if that particular manufacturer is still adhering to that policy, but
Care to
there's
name any names?
no, they were a competitor of ours in the facility control front. That's all I'll say. Um, so some manufacturers are more open to sharing their MIB files and their data via SNMP than others. The other facility control manufacturers have moved. I believe it's Davicom has a pretty nice integration of SNMP in their facilities. Burke integrates as well, but I think they're still depending on an external computer. I think running their Jet software or something like that to do the SNMP communications. So it's not all integrated into the same software, the same facility control plan. But yeah, it's in general, like I say, if they're going to publish a MIB file, they're gonna put a lot of stuff in there just to make it worth their while. I see Mike has unmuted. Mike, did you have a
Well,
question?
there's two there. I think that might be two instances of Mike. He might be
Oh,
monitoring on
oh
one,
yeah,
and
no, yeah, okay,
yeah, he's yeah. I'm assuming Mike M is Mike McGee, the second instance.
okay, fair enough.
But any other questions for Tony?
All right then. Well, again, appreciate your time, opportunity to talk to you guys.
Yeah, I appreciate
Exciting to
you
have
coming
a
by.
exciting to have an active chapter up in Canada. That's great.
I happen to have.
Oh,
Speaking
Navigator.
of legacy equipment,
Yeah, that goes back a ways. Is it still functional? The compact flash card's still working and everything?
yes, it is.
That's awesome.
Last I used it, which, well, admittedly was a couple of years ago, but yeah.
Yeah. No, I got one of those. I snagged one of the last one of those we had available because that's a very useful little Swiss Army knife for FM broadcast right there.
Oh yeah, I love the way I can, translate that data to a Google map, color
Yeah.
coded Google map.
I
That's
have a
very
friend
nice.
of mine who's a pretty well-known consultant who has one of those. He was doing due diligence on I think it was the New Orleans market
Hmm.
for a client who was thinking about acquiring a move-in signal there, and so he needed to survey all the signals in the market across a wide area. And he said, "I don't have time for this," so he found a limo company down in New Orleans, and he would just set that little navigator up in the trunk of the limo and say, "Go about your business. When you don't have a ride, just drive around wherever you feel like driving around. I'll pay for it."
Well,
And
that'll
so,
be more dense than any engineer
yeah,
would do.
so it's like, the limo company, covered this, blanketed the city nicely. It took him, about a week to 10 days to get, all the different neighborhoods, but he would get the data back every day and say, "Okay, so next, tomorrow on your off time, could you drive around over here, drive around over there?" And got it all done.
Very cool.
Yeah,
And
it was partly possible because that navigator, once you set it up, you can unplug it, and if you plug it back in again, it just pops up and continues right on going with the sweep that it was doing. So it didn't matter if the limo guys shut the car off to get something to eat or whatever, it would start measuring again as soon as they started driving.
even includes RDS,
Yeah.
that model.
So, all right, gents. Well, again, thank you very much for the opportunity, and I'm my email. I'd be happy to share the slide deck with anybody. You can reach out to Mr. Welton. He can reach me if you didn't get my email or my phone number off that last slide of the presentation. And I'm looking for work. If anybody's got contract stuff I can do.
Well,
Uh,
I think your presentation is far more detailed than anything I've found on YouTube when I was doing my SNMP research. So I believe that your presentation will end up on YouTube
yeah, it's
with your card. So
okay. That's
with
great.
your calling cards.
I actually wrote the chapter on SNMP management for the SNMP for the SBE um, engineering manual.
Oh,
They
nice.
SBE University, they have courses that you
Hmm.
can take at various different disciplines. So I wrote the SNMP course for the SBE University. So you can get some of that knowledge there. But I find, even as much as I've been into it since probably got into it about 2007 or 8 when we were putting together the Relio for iHeart. But I still learn stuff, about SNMP and how it works and how to use it. That's all the time. And I like to tell people it's not something you just open a menu and say, okay, you have to sometimes do some detective work, because not only do you have to find the data points that you want, occasionally they will return data in a form that you don't quite recognize. Um, One of the early experiments I did when I first got the MIB browser, I queried our server in the office, which spoke SNMP, and asked it how much disk space was left, right? Or how much disk space was occupied. And it came back with a number like 12. It's like, does that mean you've used 12%? Or is it, did some more research and found out they were talking in terms of cylinders of data, which is like, that's a 1970s term, and they were still using it, in a fairly modern Dell server. So yeah, sometimes you have to interpret or translate the results that you get back from SNMP to come up with a useful value.
I think when I first started looking at SNMP, I read somewhere that it had been around since the late 1980s. So
Yep.
it goes back quite a ways.
Yeah, so it's a very simple protocol. Also important to note that it is not in any way secure. It's plain text. So anybody that's on the network and can intercept those messages can generate their own and maybe cause some mayhem. So you got to keep your network armored. There is a version of SNMP called V3 that encrypts all those messages and uses a second level of password protection as well. So if you really are concerned about security, you need to find software and equipment that can speak V3.
Yeah, good advice.
Never,
Because we should all be
never,
concerned about
and
security, as
can
we
never be
we've
too
all
secure
learned
on the
in one
network.
form or another this
Yeah.
calendar year.
Well, it's
So,
whether you learn it, the hard way, or you learn from the misfortunes of others. Finding stuff that's hanging out on the public internet with the original factory passwords still in it. It's never a good
oops.
idea. Yeah. All righty. Well, I will sign off for now. Again, thanks for your time, gents, and hope you have a good rest of your day and rest of your week.